Welcome back to another episode of the Reliability Gang podcast. I'm here with my right-hand man, Will Crane. How we keeping, buddy?
Very well, thank you very much.
It's been a minute, guys. It's been a minute, hasn't it?
We've been busy launching something.
I know. I mean, the whole launch was just... It's weird sometimes when you get in these, like, we've never actually done something this big before, if that makes sense, when we're building another business unit, building the processes, and you don't realise...
The time,
the effort, the graft involved with just getting it set up and understanding how that type of business is going to work, because inherently it's just been so different to the condition monitoring side of what we're doing, isn't it? Do you know what I mean? So
do you feel like we've kind of just like been running and now we've just hit that wall and we're like, boom. It's kind of like we've launched it and we're like, oh, okay, and it's like we're here.
I know, yeah, it's a bit weird because you're right. It's kind of all of that hard work that we've put into it and all of that kind of pre-thought of what do we need? How do we need to get it sorted? What do we need to make sure it's prepared for launch so we are ready? And that's the hard thing when you're investing a lot of money, into a business where you have to have all of the things that are able to do the job, because it's not just, I need a data collector. I need someone who can, who's got good observations and is trained and understands how to collect data. This is a motor is a very different element in terms of repair to a gearbox. There's different elements in there. There's different failure modes in there. There's different things to understand. And as well, obviously, since your brother's come on, he's been amazing. He's been so intrinsically important to this whole transition, but he's highly mechanical. So we've been doing a lot of training on the electrical side of motors and stuff, and he's really picking up quite quickly. But until you had that exposure to that, it's really difficult because it's just new. Do you know what I mean? So
like we talked about, and I think everyone that's probably following us knows about detect, solve, improve. But obviously, this kind of episode, we're talking a bit more on that solve side. Since we've started with the repair centre, we're going to explore some of the things that we do a part of solve. You've kind of really looked after the repair centre.
It's been my baby.
Do you want to talk a bit about what we do in the repair centre now and why we started all of that?
So obviously, when the vision for me was always detect, solve, improve, and when we kind of manifested this idea about two years ago when we're looking at reliability, and it all came from that transitional part of maintain condition monitoring when you started, because we did that very well. Me and you were both, I was level 2 when you come on, I got my level 3. You still had a lot of experience in condition monitoring. We were quite seasoned when you first come on. We had quite a bit of experience in that. And one of the things we were finding that we were just given lots of problems, and there was it was difficult for us to see the value in it, because it was the whole part of the reason why
we were in COVID, weren't we, as well, where a lot of maintenance teams were stripped back.
They didn't have the availability, and it was that's kind of where it was born, really. And I think where we've evolved this is just from our experience. It's not something that has just come about and we'll do that. This is definitely based upon data that we've found with our customers
and feedback
as well, because
when you guys do that
and we were engineers. We were mechanical engineers. I've changed plenty of bearings in my time, and so have you when you was in your apprenticeship with British Sugar. That's where you started. That's what you did before you got into.
And everything we did then was in-house.
It was in-house. You was taught very well. You had and we had all this extra knowledge that we weren't able to utilise. Do you know what I mean? So this is where the transition came. Was right, we need to become more than this. We can start doing the recommendations. But what we did want to do, and what we did have, is a precision maintenance mindset, because everything we did, we wanted to be perfect. And that was we have that weird OCD perfectionist side, and it can be annoying actually that we
sometimes you have to say not right now.
I know, and do you know what? Having that extreme OCD in a business sometimes is so difficult, because you want everything to be perfect, but
it's not possible.
It's not possible. So you're always trying to aim for that extra level, that higher level that doesn't actually sometimes exist. But the thing is, when it comes to precision maintenance, we can provide a precision alignment to a certain tolerance, and we can do that, and we want to be able to achieve that, and we understand that if we do that, the difference it makes a reliability. So that's the whole transitional stage of maintain condition monitoring to reliability. But then it was a case of, well, great, we can now do a bit of this, and we can solve the problems, and we changed bearings, we found electrical fluid,
and it's quite rewarding as well if when you've identified a problem, you're able to do it, and then you test again, you're like, boom, Yeah, made a
I
difference.
mean, it's that one we did for one of our customers, big compressor. That was our first bearing change that we did. Electrical fluid that we found within the bearing. You know, we put a shaft current device and it worked very well. And we solved that.
Yeah.
And we improved the reliability of that machine. We're still monitoring that till this day. I mean, that was
no defects.
No defects, and it's still going. And we regularly shaft current test it as well, just to make sure the device working.
Before then, every 6 months it was failing.
Every 6 months. But that was the first job that we did that was, wow, this model could work. Detect, we understood that it was a bearing defect, outer race defect from our collector. We've gone in there, we've helped the customer on a shutdown period where it didn't impact their production. And if they lost this compressor, the whole plant is down. Like, this is like the holy grail on this side. They are very conscious of this. And it's good that they know that it is a reliable, it is a critical piece of equipment that needs to be reliable. So when we did that, that gave me and you just this fire, didn't it? I mean, I think...
And I suppose that was the birth of Solve.
That was the birth of Solve. Because the thing is, for us, we love the condition monitoring and we love the identification. But what we didn't like was closing the loop. What we didn't like was when something did get repaired, where's the bearing? What happened? How do we know that change or that rectification is being done in a way that has actually made the plant reliable? And we was missing that information quite a lot. I'd say 80% of the time that when we was requesting certain things, we weren't getting it. So the thing is, if we was in control of the whole thing, we could get the bearing, we could take it out, we could do a root cause analysis on that. And then what we could actually as well, when we are actually putting that back in or we're realigning something, we can understand the implications of what was done wrong, whether it's poor lubrication or whether it wasn't even fastened correctly.
I suppose that was like, before we get onto Repair Centre, that's when we really started offering engineering services as an offering. After that, it was like, there's two of us now. A lot of the time with engineering stuff, you need an extra pair of hands sometimes if you're doing a heavy lift or something. I
remember we bought the caddy, didn't we? We bought the van for that purpose, because we was obviously at the time had our cars and we was loading our cars with these tools, and it was
my car was like on the floor.
Didn't need to lower that, did you?
No.
Oh my God, Oxy settling in these and they were quite nice cars, to be fair, at the time. This is crazy. So what I did, I'm getting a van, and I drove that around, didn't I? And then whenever we had any engineering jobs, I loved it. I loved the fact we could just load it full of tools.
And we started doing all sorts of engineering services, bearing replacements.
Yes, bearing painted on site.
Shaft current testing as well, which was a big one because everyone that's moving on to VFDs.
Huge one right now. I mean, I visited a customer, this Monday, and he won't even mind me mentioning him. Lance, great guy, British Gypsum, incredibly, just such an advocate for reliability. This guy, like, honestly, it's so refreshing when you can have these conversations. And he's done an amazing job from the bottom as an apprentice, moved all the way up in terms of his position where he is, with a real good rapport with his guys and great teamwork. And we're now looking at, really the top end of reliability, looking at the plan maintenance.
Juicy bits.
We're now getting the froth, but we're looking into, they've had some issues with some VFDs and some, electrical currents. And it is not a common thing. They've got a lot of motors on site, but it's going to happen, and it's going to be happening somewhere.
And it's random.
It's very random, and that's the thing. Because it's random, you have to be able to create a PM for it, a plan maintenance task for it to be done regularly, depending on, I don't know, frequency wise is subject to different, different criticalities. But again, it still needs to be done all the time. And that's something that we've identified and something that we're implementing. So we've done a lot of Famicas on 4 kind of major AA kind of machines. And we're now doing that extra bit. But I suppose that's where Solve does come into it a little bit, because they already have a condition monitoring program in a minute. And I'll be honest, it's effective. Do you know what I mean? And don't get me wrong, there's ideas that I could put in there, but it's doing its purpose in terms of identification of defects. So the idea is if, you do currently already have condition monitoring, doesn't mean that we can't work with you.
Yeah.
I think that's a perfect example of a customer. We've come in and we're just having a look at the gaps that we can fill, and we can come in and add value,
But that's because we're not a condition monitoring company.
We're a reliability company. And that's why the transition was so important, because, if you can't transition to that solution place, what are you actually effectively doing? You're identifying things, but you're identifying problems. We need to be solution-based people, and that's always been something that we've been passionate about.
Yeah.
This is why we had to build a repair centre.
Yeah.
Because when it comes to a stage where you are on site or there is a job and there's something that can't be done on site reliably, you need
Or
to
the right
have
environment.
or the environment to be able to do so. You need to have somewhere that allows you to be able to do that repair in a reliable way, and something that you can as well measure, measuring the tolerances of the housings, measuring all these things and having a standard as well to that, to say, look, if it does exceed this, and the same with the winding.
Traceability as well.
Traceability, we had a submersible pump in the other day, and Harry was working on that last week. And, Mega ADX tester, beautiful piece of equipment, identified. And when we were surge testing this particular winding, right, about 1,800 volts on the surge test, there was sparks within a turn-to-turn fault, right?
Oh, wow.
So when we measured this out, if you just measured it with a normal mega,
You
would not have seen that defect. 100% not.
Okay.
But it's not been seen. So this is another thing why, I spoke to Michael Herring as well, incredibly knowledgeable guy, right? He come over, teach me and Harry for a good 2 hours, 3 hours, and it was a great session about teaching him why surge testing is so important, because turn-to-turn shorts are very, very common. They're the ones that are going to kill your winding, essentially, okay? And if you're just doing general resistance checks between, on your phases, or you're doing insulation resistance checks between phases, it's not taking into account turn-to-turn shorts, right?
And this ADX tester that we've got in the workshop, we can take this to site as well, can't we?
We can.
And we can do like motor stores and stuff like that.
And this is a discussion I was having with Lance as well. So obviously they've got a planned maintenance function for that AA critical kit, of where they do go and they do mega checks, but they don't surge test.
Oh, okay.
So now you've got an element there of a potential failure on a critical piece of equipment for turn-to-turn shorts, right? That's not being covered. So that's something that we're implementing back into that to make it improve it a little bit. Do you know what I mean? So it's now about looking at all of the processes and looking at all of the failure modes, because you can't just assume, okay, you might identify in your Formica that, okay, the winding can fail, but how you almost need to look at how it can fail, and every avenue. So rather than saying, oh, we're just going to mega it, well, what does that mean?
That's your cause part, isn't it? When you say winding might fail, what is the cause?
What's the cause? Turn to turn,
this
phase to phase, overload. Do you know what I mean? There's lots of different considerations, but this is where Formicas can get complicated, because if you don't fully understand the elements of electric motor, how do you know how it can fail?
Yep.
Does that make sense? So I think this is where we become a little bit more kind of intuitive into the fact that we can do this a little bit more strategically, in the sense that we understand how a motor works. We understand how a gearbox works in terms of its functions, in terms of pinion gears and gear mesh frequencies, and what's the importance of oil. We're kind of not looking at it as just a consultancy point of view and coming in and just doing our RPN and just saying, oh, what's the risk, and just kind of whacking in figures and data. We're looking at each case as an actual engineer. Do you know what I mean? And that's rare. I don't feel that everyone can give that perspective of things, and I think that's exciting for us.
It comes from a place of experience, though, doesn't it?
It does. You can't buy it. You got to be in the field. You've got to be testing these motors. You've got to go and do the seminar with bloody Michael to tell you about these things, and almost of course he's out there to sell these pieces of equipment, but their sales strategy does really go on the fact that you need to do these things for reliability, and that's what everybody's looking for. So the identification of that turn-to-turn defect, incredible. And I know what a lot of people might say. They might say, well, the motor's only running 415. But every time you start that pump, that surge current can get easily even above 2,000 volts, right? And you have to remember, we're testing DC. That's AC voltage going through that winding.
In, out.
So every time you start that motor, the potentiality in terms of that fluctuation in voltage can reach up to that. So this is where the reason why we test at 2,000, because that's generally on the start the max potential. I mean, I'm not saying that's the same for every winding, but there's a potentiality with it. So this is why we set that standard at 2,000 volts and say if it doesn't exceed that, we can't put it back in, because how can you trust that?
Yeah,
you can't. It's unreliable. So now we have to get it rewound. We get it rewound, we get back it to the standard it should be. Do you know what I mean? And then we do the mechanical part as well with extreme precision as well. Make sure everything is done properly. The bearings are fitted properly with proper induction heaters, and we've got a process in terms of how we install bearings and how we put things together.
And that's that precision maintenance part, isn't it? We use proper installation techniques for bearings. We do laser alignment. We've just got our delivery of our new alignment.
We have,
kit.
yeah. Thank you, AquaM. We've been eager.
I'll be putting a post out later. I'm going to get them all unpacked.
Yeah, definitely. I think we both want to have a good play with that. We were so busy yesterday that when they arrived, we had to go out to a meeting. It was horrible. It was like, just let's have a play. We couldn't even have a look at what we received. So we'll be back in there today to have a look. So we have got 2 of them. We've got one going up north, and we've got one here. But again, incredibly accurate alignment.
And it's
equipment.
not just about with precision maintenance for laser alignment. Excuse me. It's not just about getting additional reliability. We get that. You know, when we laser align something, it's going to make something last longer. But there's some energy cost savings to be had massively with laser alignment.
Yeah, I agree. 100%.
Huge savings.
Massively. And I think what was a study that AquaM even said that if you had all of your equipment aligned, the energy saving was quite high. I can't remember what it was.
It was enough to turn your head and go.
It was, yeah. And it's something as well that you disregard. You don't think it has a big difference, but it's a bit like the air leak situation where loads of little air leaks add up to a huge amount. And the idea is sustainability needs to be focused on the fact that anything that we can do to improve it, we need to do. You know,
and laser alignment as well isn't too taxing. It's not difficult. It's not too complicated. You need to have the right technical knowledge about how to do it depending on the machine. But it's not like a task that if you wanted to get done is going to cause you lots of downtime.
No, I agree. And that's what we're doing as well. When we spoke to Lance about having a look, he's got a lot of couple drives. So a lot of the time they do a lot of coupling checks. Right. Well, now we can do an alignment check as well, just to make sure that it is an alignment. And a lot of people think, well, how was that? How would a machine move? You'll be so surprised about machines that we've thought, how the hell is that mower that size moved? And they do. They do. We've had it before where we've checked alignment year on year on very big applications that you just never think would just like, how was that moved? And we have evidence that there are times where we've seen, and okay, it might be very small tolerances, but still them tolerances, if they move out of tolerance, means there's potential damage to the sum.
How long are you going to wait until you next work out that, oh my goodness, now I'm massively out of tolerance?
Exactly. But then how long as well has it been running in a state of poor alignment? You don't know until you do the checks on that. And that's the thing as well. What we can do is, and what we have been doing with some clients is not getting them to buy 8400. That's obviously the extremely higher end piece of equipment that we would use as service providers. But what we can do is offer some training, because we can't be there all the time. And if you want to use this as a planned maintenance function and add it to your PM structure in terms of what you're doing, well, then we can give you some training, and we can sell you some kit as well.
It works really well with our customers that we do condition monitoring with that are using Nest Vision as well, because they can upload their alignment data straight into our in the dashboard.
And that's another beautiful thing about Nest Vision as well. And I think what we probably will do is a separate podcast on that. Talk about how we're starting to now integrate people into more of a cloud-based kind of world. How is it valuable?
Yeah.
And why is it important to have information in a single place? Because ultimately what we do is great, but if it's scattered information, how do we pull it into somewhere? And Nest Vision it's incredible actually how they've managed to be able to keep all of these things in one place for the customer. That's another separate podcast, which I'm quite excited to be able to talk about. But getting back kind of to the solve area, laser alignment, incredibly important. And that's something that we do for a lot of our customers. And it could just be, from a bearing change of what we're doing. If it's a couple pieces of machinery, we can do it. Maybe it's just a check.
We've done lots of checks. We've done engine checks on boats, but that don't warrant a full alignment, but they just want a report to say, can you verify that our alignment is within tolerance?
Exactly. And I think that's as well, if you do have, and looking at more of a reliability kind of function, if you do have a lot of coupled drives and you're unaware and you haven't had anything checked in a while, it might be worth looking into just maybe getting some initial checks first, because a lot of people say, well, we've got vibration analysis, that'll pick it up. Not always.
Yeah.
And I'm telling you now, it's a myth that if you have misalignment issues, right, there's a lot of factors that can get in the way of the fact it coming in even into your vibration data.
Yeah, dampening
in the coupling structure. Exactly, that type of coupling is extremely important.
And to tie on the type of clutching, we hear quite a lot with. In some engineers who will say, well, it's a tyre coupling, it can allow for misalignment. And the thing is the coupling itself does have a tyre coupling in particular will have a high level of tolerance for the permissible misalignment of the coupling. not of the seals, a mechanical seal, the
bearings and all of these
else.
things. And that's another thing as well. It's another myth to say, oh, we don't need to align it. We've got a tire coupling on it. Complete BS, guys. You need precision alignment
by Maintain,
mate. I will stand by that every day as a reliability advocate and evangelist. But that's what we're trying to do, and this is why we're here, because ultimately what we're trying to do is spread awareness and information. Because, like, let's be honest, you might not know that it will have a difference, because you look at a tire company and they look very flexible, don't they? And you get the assumption that it might be okay. But this is where precision maintenance comes in, and this is where the solve part of Maintain comes in. And alignment is going to be a real big driver for us. So whether you're in the north, whether you're in the south, and we travel out as well, we've got 8 engineers now in total, including us too. We have coverage in the UK, and this is something that we're taking very seriously now. So alignment strategy, if you need help with it, get in touch, guys.
Training or
training, or even if say you want have the kit, we distribute the equipment, right? We're authorized distributors for this equipment. We can give the training and sell you some equipment, and make sure when we leave, you're capable of using it and adding value. That's the most important thing. And I'll be honest, the AquaM alignment gear, best I've used.
And the most important with that as well, I want to drum home, is the consistent support thereafter. Because you are always going to be in a situation where you can teach as much as you want. We can teach you as much as you want in a classroom environment. This is how you do a laser alignment, or out on plant. And you're still going to be in a situation one day
you need help.
Where you need help.
We've been there.
Just call us.
We've been there. We've been there ourselves, haven't we?
And we can advise over the phone, or
and we've been in a field where we're scratching our heads and we've learned the hard way. And then when you get the realization, like, oh, okay, that's throwing it off. And that experience you can't teach. You got to be in the field for it. But if we do sell you any equipment, we will be there to support you. That's just our nature as the reliability gang. If you indoctrinate into the reliability gang, like, we're here to help. Do you know what? Even if you need some advice or help, throw it our way anyway. Because that's what we're about, mate. So we don't. Yeah, exactly. It's not all about that. So alignment is a huge one, and another one. For one of our customers, actually, we've got an engineer there, nearly half of his time, doing a range of different things. So planned maintenance.
Oh yeah.
Is something as well that we're starting to pick up, because what we can do on the reliability function is actually are your planned maintenance functions actually valuable to your organisation, right? And we'll get onto that a little bit later on, probably in another separate podcast on PM optimization. But we're looking at more of the solve part. And once we've kind of done that, the idea is, well, why don't we use our technology with the PMs, a bit like we're doing with Lance, using ADX, using alignment, using some really cool tools to make the PMs as highly as effective as possible, right?
And looking at the Famicas that we do as part of kind of Improve and the reliability stuff, to look at that, there are going to be some failure modes that we identify that maybe are quite hard to detect.
Yeah, definitely.
That maybe need to have, the cover taken off and had a good look inside it. And that's where Lewis, he's working with one of our customers, doing a lot of planned maintenance support, because they've recognised that they do have tricky to access assets. They do have machines that are start, stop, tricky to collect data on, very small windows.
Yeah.
That he's doing a lot of their PM checks, which involve, mechanical seal inspections. Might not necessarily detect a fault with a mechanical seal through vibration analysis.
Exactly. And the good thing as well, what he's there, because he's on site for that period of time, he integrates with the maintenance functions. So if there is something that he can solve,
CMS.
Right, he can put it in CMS, but not only that, he can solve it. So he can liaise with the plant operators, get it locked off, search for a maintenance window as well, and actually go and solve the problem on site. So rather than just us being, oh, you got a problem here, that needs inspection, this whatever, we want to say, well, no, we've identified it, and now we've solved it.
He's done really well over this particular customer has 2 sites. We call one main site and one east site. And over at east site, they've got a lot of extraction fans. And so what he's been able to do is, using the vibration data that we collect every month, identify that there's an imbalance. He can then, which we'll touch on in a minute, he's able to then balance the fan. But while he's balancing the fan, we're taking guards off, we're doing stuff,
doing a proper
inspection, checking the belts, setting the belt tension. But because he's there and supportive of able to do all of those, it's all pulling together. And fan balancing is another huge, important task of ensuring the best reliability of the machine, because we know when a fan is out of balance, bearings aren't particularly happy.
No, they aren't. And as well, that's going to obviously cause that machine or whatever it is around it, whether it's fan bearings or motor, to fail a lot more quicker.
Vibrate, fatigue, cracks.
All sorts of different problems, not just the motor or the fan bearings you're looking at. It's all sorts of different issues that can come off that. So that's what we're trying to mitigate, and we're trying to be able to solve as well. So again, it's a little bit of a different model to the general consensus, but it works highly effectively when you can have someone with good condition monitoring experience and understanding how to use the equipment, good engineering knowledge, but not only that, integrated within the site process.
Yeah.
So what it is a case of is not just giving loads of problems again, he's actually liaising and planning and scheduling this work in. Do you know what I mean? Which again takes time, doesn't it?
Instead of having us come in and doing it, and for a lot of customers that works, comes in, do a fan balance, come out, or do a laser alignment, or we go in once a month to do certain PMs. What we do with this particular customer, which works very well, is what Lewis is he really is a focus as a preventative, proactive, and predictive maintenance engineer.
Yeah, I love
precision.
That. And precision,
it lets the maintenance team on site do is it's a top tier coma site, so their engineers really focus on the stuff that we can't really get involved with, the high level stuff that needs a lot of site level knowledge. Their team can focus on that. They can focus on the things that do react, and they have to react to because they're still on their reliability journey. They're not quite there fully yet. But what Lewis can focus on is making sure that, the PMs are being completed, that are not going to try avoid catching them out. The precision maintenance is being done.
Yeah.
Trying to keep up with those things that, I've identified that the fan's loose or the fan cow's loose. Seems a really minor thing.
But it's important because, if that gets loose and it falls off, and then there's a health and safety risk. And that's the thing as well about obviously mitigating, looking at more the health and safety side, especially at a tier 2 coma site, that if you can get the reliability right, the risk element of health and safety or explosive atmosphere, it reduces massively. So this is where as well, it is obviously for compliant reasons as well, to be compliant, but it is to be to try to be better with health and safety, which also has a byproduct from being more reliable and obviously putting these things in place. Hence why this is a very successful strategy at this particular customer. Do you know what I mean? So, in terms of that solve part and the planned maintenance part, we can help out massively as well. So what we covered, just want to make sure we've covered everything.
Engineering, bit on engineering services. We talked about the story about the compressor. We talked about planned maintenance and the stuff we're doing, and Lewis is doing really well, and we do for other customers.
We talked about alignment, didn't we? And fan balancing.
Fan balancing.
Yeah, the other services we provide.
You've got into a bit of the repair centre, or do you want to go in a bit more deep?
Well,
the capabilities that we can actually do
I think we'll just finish on the repair centre. So great example. Harry went to site with me, actually. We went together on this job because I wanted to get my hands dirty,
can't stay away from it.
Can't stay away from it a little bit. Yeah. So we went to site, and it was really basically what we identified was a bearing defect. Well, a dry bearing on a sealed motor, on an actual motor, and the bearing block completely over lubricated. Right. Okay. So we've identified.
What's the machine?
The machine is a gas booster.
Okay.
Gas booster pump. So what the scope was just a bearing block replacement, replace the motor, good to go. Right?
Sounds easy.
But we know that, the thing for me was like, okay, in premise, quite an easy job, take the motor off, obviously replace the coupling. But as we started to do the job, we just started to find more problems. So initially, when we took off the cover for the coupling, right, the customer did not have the right coupling, right? So we found the coupling completely damaged, right?
Oh, really?
To be fair, in terms of vibration we didn't really see that because it was one of them kind of cylindrical couplings that kind of clip in.
Yep.
So it was very rusty and it hadn't been lubricated either. So you have to lubricate this particular coupling as well. So that was a problem, an issue. So we managed to get one built and machined extremely quickly within a day. They had a 3-day shutdown. So that was the first issue or problem. And the second issue was obviously to replace the bearing block. It was obviously a solid unit. So it's not a plumber block bearing assembly. You can't take the bearings off one side. We had to take the impeller off to get the assembly off to reinsert it again. And I'm telling you, this fan impeller was not coming off. We tried everything. And obviously the site conditions didn't allow for us to be able to use any heat. So we had to get it back in the repair centre. And guess how much, right, tonnage pressure it took to get this shaft off the hub.
This was after we did try heat in the repair centre.
Oh my God. So we actually, so we're in the repair centre now, obviously used some heat to try to get it off.
hydraulic pullers.
And the hydraulic pullers, and 9 times out of 10, mate, usually the hydraulic pullers will be able to get it's not a massive fan, by the way. You know, you're talking the hub was you know, shaft size was only what?
100 mil.
Yeah, not even that. Mate, I'm not sure Harry would have measured everything.
Yeah.
But again, it took 45 tons of pressure.
We had to cut the monoblock in half to pull the fan and shaft through to then put it in our 100
press, and we got it out. And obviously, you should have seen the damage. I might even put some photos in if I can read
it. Because of the environment this gas booster was in, it had basically welded itself to the shaft,
and it was complete. The hub was completely damaged, so had to be remachined. So we got our trusty partners on that, and they turned it around extremely quickly, straight keyways completely obviously machined in as well with the coupling, because the coupling was machine fit to size. Got them installed, got that completely realigned at the workshop as well, because we had the whole unit.
Yep.
So we was able to do that. We give it the new motor ADX test as well. We checked the motor as well, give that element there as well. When we got it back to site, did a quick alignment check as well, just to make sure everything was good, all good to go. And it all got wired in by the electricians, and great.
Jobs are good.
But
it sounded really easy, but
it sounded easy, but it's so stressful.
It's like, I've got to get this back.
What's going on here? This is again, it's still a bit of a. Obviously, they needed it running,
but the difference.
But we managed to make it reliable.
We did, but also off the back of that, we were able to issue a number of recommendations to the customer to ensure that it wasn't going to happen. And not just that, there's also design recommendations in that as well that we're looking to work with that customer on. Not something we really could have implemented there and then, but fundamentally, it's not the greatest situation to be in to have to cut the monoblock in half to pull the shaft out.
Yeah.
And what we were able to do is, using our engineering knowledge, mine, Harry's, yourself, come together with a design modification on the fan that we were able to then submit to see if we can potentially put something in place to prevent that happening again.
Exactly. And now, obviously, what we've done with this particular customer as well, the lubrication schedules, because we was only doing once every 6 month checks before they're shut down. So now he's agreed that for the critical assets, we're starting to do more condition monitoring. So monthly surveys now. But what we've said to him is, look, in terms of the greasing schedules, I think what's been happening is they've been doubly greased to OEM standards. So I think there's 2 people doing it, which has caused the issue to happen. So we've said, look, we'll look after that now. So now there's no problem with that getting over grease, because I tell you, the amount of lube, it was because the whole block was full of grease. So again, this is a problem that has been induced. Again, well, not always, like even when you look at lubrication schedule, not always the best practice.
When you look at, I've just come and just finished my ultrasound course. Shout out to the guy at UE, fantastic. But we talked about, everyone knows, you know, lubrication is one of the biggest causes of failure that is about. But one of the things Craig said, and you know it, but you just don't think about it. When you think of, you know, lubrication, big cause of failure, and design, they're usually the top 2. What do they both have in common? Human
error. But guys, that is our kind of 30-minute up for this podcast. But if you are interested in any of the Solve services that Maintain and what we can do, the idea is there's lots of different things. So guys, usually it's just a chat and a discussion to see what your process is, and if there's anything that we can implement in there, because you might have a really robust, you know, maintenance department anyway, but there's always somewhere where we can help. You know, Lance is a great example of that. They've got a great team. But what we're doing is looking at more of the reliability elements, but, you know, helping with their plant maintenance a little.
Anywhere from us coming to do it to us supporting you so you can do it.
Exactly. Anywhere in
reliability together.
Improving reliability together. Thank you, guys. Take care.